Good morning, guys. My name is Brian. I'm doing a 6-minute talk about forced induction. Forced induction is basically just ways to get more air into an engine. This is my buddy Morris Malone's twin turbo Corvette. Makes like 3,500 horse. It's stupid fast. So engines need 3 things to perform. They need fuel, they need an ignition source, and they need air. If you increase all 3 of those, you get more power or efficiency out of your engine, depending on what you're looking for. Today we're just going to focus on air, because that's what forced induction is. It's just forcing more air into the cylinder so that you can get a better burn. Forced induction just basically, its primary purpose is just air delivery. And they do that 2 ways. You have a turbocharger or a supercharger. We're going to go over the difference of both. This particular picture is a rotated GT35R that I set up on my buddy's STI. We're going to start with superchargers. This diagram right here is it's just called a screw type supercharger. You can kind of see the screws here. It's not to be confused with the roots type, but they also have stuff such as like a centrifugal supercharger, which is, we'll talk about that in a little bit. But the difference here is that the rotational motion that it gets is belt driven, so it runs off the crank of the motor. This application is really only good for cars that originally make good power or they rev really high so that you can get more air flowing. If you put a supercharger on an engine that doesn't make much power to begin with, you're not going to see as much gains. Other than that, this is kind of like a diagram. You have a tensioner, and then that kind of just supplies the tension to make sure that the belt stays on during boost. The belts run off of the crank of the motor, like I said. It's not really aligned here, but the crank would be here, so these would be aligned, but this is just for purposes of seeing it. So it goes through this roots type supercharger, usually comes in the back, and then it goes down, and sometimes they utilize a heat exchanger, or they call them intercoolers in the automotive community. Because whenever air gets compressed, it heats up, and you want cold air in the cylinder, so it'll run through some sort of heat exchanger, and then down into the cylinder to be combusted. And this bottom picture here, this is just kind of this is an application picture. This is that's a factory roots type, or not roots, screw type supercharger that comes on the Shelby GT500. Turbochargers work a little bit differently. The way that they get their power is through a turbine, which is connected through like a journal bearing, or they call it a CHRA. It's a centrally housed rotating assembly that exists here. So basically, as your engine produces exhaust, it builds pressure up in the exhaust manifold, and that is shown here. So pressure builds up here, and it spins this turbine wheel, which in turn spins this compressor wheel and sucks in more air. So the more exhaust your car makes, the more air your car is going to suck in. So the more pressure you have here, the more pressure you're going to see on the opposing side, and that's called boost. So as your car RPM climbs, the amount of exhaust gas that it produces increases, and it increases that pressure, which in turn sucks more air in. Same kind of concept here. The air comes in through the compressor housing and then goes through what's called an intercooler, same thing as on the supercharger. This BOV stands for blow-off valve. It's basically a pressure regulator so that you don't overboost and break stuff. It's usually like a spring type pressure regulator, so once it sees a certain pressure, it'll release it out to the atmosphere. They have something similar on the exhaust side that's not really shown here. It's called a wastegate. It's the same kind of principle. We'll go into it here in just a second. The advantages of the turbochargers, you can put them on engines that really don't make much power to begin with and see better gains, just because it's much higher rotational speed. They see over 100,000 RPM usually in turbos at full boost versus 10,000 on a high revving engine on a supercharger. There's a lot more plumbing you can see because you have the 2 basically pumps, and you can usually crank more out of them. Here's kind of another diagram of one. It shows a wastegate. The main difference between a blow-off valve and a wastegate is this is on the cold side, and that you can release it to the atmosphere because it's just regular air. There's no exhaust involved. But a wastegate has to be routed back into, well, on regular cars, it has to be routed back into the exhaust. That way you're not just blowing that off to the atmosphere without it being treated through like a catalytic converter or anything else like that. On race cars, they just fed them to the atmosphere because no one really cares about emissions in racing. The applications, basically the applications is just like crazy. So like down here, Ford developed a 1 liter EcoBoost, which is ridiculously small, and they just put turbos on it to increase the power. It's a smaller engine, so it's just a lot more of an efficient way to get better gas mileage, and then obviously you can put them on race cars with big turbos and have a lot of fun. The relationship to thermodynamics, it employs the use of a heat exchanger or an intercooler, a pump, and a turbine if you're using a turbo. Basically, the whole idea is to get more cold air into the cylinder because you get a better burn. And this is a compressor map, which is really kind of similar. It's what us gearheads use to size the turbo that we're going to put on our cars. You see it, you calculate your airflow that you're looking for, and you size that against your pressure ratio to find where you are in this map, and then they have the manufacturers of turbos bring that into their brochures. Summary. Turbos, and first, force induction maximizes power and efficiency, and it can reduce fuel consumption if you reduce the displacement and put a turbo on it. They sound really cool, and fast cars are a ton of fun, so that's why I like them. Here's my references for all the pictures. No question.
On that pressure flow rate diagram.
This compressor map?
Yeah, I'm guessing the pressure ratio is in the cylinder, desired pressure ratio, or is that on different sides of your turbocharger, or what?
So this is a compressor map. So this is mapping out like the cold side. So yeah, the pressure ratio would be like it's basically a ratio between ambient pressure and what's going into the cylinder.
Okay. And then what's the air flow? That's just through your compressor?
Yeah, that's all. You can size this against like how much your engine can actually make. So like your engine can go, like say you can go 6,500 RPM. Your cylinder displacement can only produce so much airflow. And so whenever you kind of take a look at that, you're almost kind of estimating where that target's going to be. So if I'm saying like my heads can flow 300 CFM, then I'm here, right? And then you have to take a look at the pressure ratio. Like say your heads can flow 300 CFM, but the turbo or the internals of your say your rollers can only handle like 20 psi. Then you have to take a look at the compressor ratio or the pressure ratio. And then you kind of meet them in the middle, and then like you can go look at a Honeywell like brochure. They have a compressor map in there that actually places, like say like a 35R sits right here, right? That's just for like example. And you're like, oh, okay, bam, there it is. I'm running a 35R, and that's kind of how you size that. And if you're running like a twin setup, then you basically take your displacement and cut it in half, right? So like this guy here, this is my buddy. He has 2 turbos that are about like the size of me. They're 88 millimeter Pro Mod turbos. It's ridiculous, and it's a 400 flat LS. So basically, he has 200 cubic inches on each turbo, and his heads flow a certain amount. And also, he has a custom intake manifold that you have to kind of like. It's kind of weird to size stuff like that because it's all custom. But your heads basically are the limiting factor for that CFM. Because your engine can always put out more CFM than like your heads can, because it's just a cylinder moving up and down, but getting the air in there through all those little channels down into the cylinders was the hard part. That's why they have stuff like porting and all that. Question? Everyone's looking at me like I'm crazy.
Which one's more efficient, a turbo or a super?
It just depends. Like the NHRA dragsters use a a big supercharger and like alcohol fuel is ridiculous. But
Like
they're
a
also
normal car?
you'll see turbos more commonly nowadays. Like all the EcoBoost motors in the Fords are turbos. It's more efficient because a supercharger actually decreases fuel mileage usually. It's more for like people that like to have fun, and it's usually a cheaper setup because there's not as much plumbing. But a turbocharger, you're not taking rotational energy from the crank to turn that, so it's a little more efficient. It's just stopping the exhaust. So.